Second, I'm fixing my mic. Then hello, hello, mic testing 1 2 3. Is audio fine now or yeah? Hello, if audio is fine, then I will start. Yeah. Okay. I think I am live now. Like Takashi is planning to eat and dishes. The diet dish he plans to eat is sweet if SI is sweet or and salty if SI is salty. If he eats two dishes consecutively, he will sick and be unable to eat any more dishes. Determine whether he can eat all the dishes. So like so yeah, like am I audible? If everything is fine, then I will start. So some people in the chat like okay, thanks. Everything is thanks Mitali and RPX. Let's get started now. So the first problem says Glutton Takashi. Takashi is planning to eat and dishes. The art dish he plans to eat is sweet if SI is sweet and salty if SI is salty. If he eats two sweet dishes consecutively, he will feel sick and be unable to eat any more dishes. Determine whether he can eat all the dishes. So what it says is like first thing, like although it's nowhere mentioned, but it's saying that the art dish someone eats is this or this. So probably it does not leaves room flexibility that we can rearrange the dishes. Like it does not says right we have n dishes. Some of them are five of them are sweet or 10 of them are salty, something like that. It's explicitly saying that art dish he plans to eat is either sweet or salty. And then it says one more thing. Like if he eats two sweet dishes consecutively, he will be sick and be unable to eat any more dishes. So another critical part over here was okay, like he can eat two sweet dishes, but after that he will not be able to eat any more dish over there. So and like that was also one of the corner test case here as well. Here like he first eats sweet, salty, sweet, sweet. Now he cannot eat any more dishes, but he only wanted to eat four dishes and he has already eaten four. So the answer here is yes. So that was another case over here. And pretty much that was the idea for this problem. So the main idea is ignore the last dish and check from 1 to n minus 1. Are there any two consecutive dishes which are sweet? If yes, then print no, otherwise you print yes. And that was the solution. Like I was also confused by this. Like it says he can eat two consecutive, but he cannot eat any more after that. Like a lot of people might have assumed that eating two consecutive dishes is also not allowed. Yeah, you can ask some general question at the end of the chat in discussion. So like here I am checking up to n minus 1. If there are two consecutive dishes which are same, FL is false, and if FL is false, print no, otherwise print it. And like that was another edge case. Like, are there any more questions on the first problem? Like I will jump out to the second problem, and if there are any questions in the first, I will take them after I am done discussing the first problem. Second problem. Here it says there is a grid with H rows and W column. Let Ij denote the cell at the ith row from the top and jth column from the left. Cell Ij is empty if Cij is dot and is not empty if Cij is hash. Takashi is currently at cell Sij and he will act according to the following rules for I equal to 1 to x in the order. If the ith cell of x is L and the cell to the left of his current cell exists and is empty, he moves to the left, otherwise he stays at the same cell. And similar for left, right, up, down. What it says is so like we have a grid. We have a grid like this. Some of the places here are forbidden. Not, I don't have a very good drawing, but yeah, some of the places you cannot go, and some of the places you can go. You are also given some starting location, let's say here. Then when you move left, you can go this side. When you move right, you can go this side. Up means this side, down means this side. Another thing is, like, let's say you are here and if it says to go up, but up is not allowed, so you remain at your same position. So the necessary condition is, if you are at some place and if you have been asked to move in some direction, that cell should exist and that should be empty, then only you can move to that direction. Otherwise you can ignore the instruction given to you here. And at last it asks us to print what would be your final location if you follow all the instructions, if you try to follow all the instructions that have been given to you. And essentially that was the solution. Like, so I can quickly jump onto my solution here. So like, I first take all the input and all the strings as input, and I also take the set of instructions as input. To just make it zero based indexing, I did x minus minus y minus minus. So now I iterate on all the instructions which have been given to you, and I try to find what is will be new cell. If it's left, y minus 1. If it's right, y plus 1. If it's up, x minus 1. If it is x plus 1. Then I check first that the new x coordinate should be within the grid, new y coordinate should be within the grid, and new xy coordinate should be empty. If it's empty, then you go to the new cell, otherwise you keep your cell. And once you are done with simulating all the instructions given to you, you again print, because it is one based indexing, you just add +1 and print. That was the solution for this problem. Any questions on this problem before I move on to the next problem? Okay, I will move on to the next problem. It says there are n dishes. Add this as sweetness AI and saltiness BR. Takashi plans to arrange these n dishes in any order he likes and eats them in that order. He will eat the dishes in the arranged order, but he will stop as soon as total sweetness of dishes exceeds X or total saltiness exceeds Y. And it also asks us to print minimum number of dishes that he will end up eating. So again, the same idea, like, so like we have some dishes and we have some saltiness AI, A1, B1. And so on. So then let's say, like, this is the order after we have decided to rearrange in some way. And what it says is, like, now you are eating, and as soon as your sum of, let's say here, sum A is greater than X or sum B is greater than Y, you break. And it asks us to find minimum number of dishes we can eat. So the idea is, let's say we have eaten some set of dishes, and when we stop, either sum A would be greater than equal to X or sum B would be greater than equal to Y, right? Because that is the only condition when you break. My idea is, like, let's assume that this was the condition when you break. If this is the condition when we break, then, like, it's better to just take all the dishes with highest value in decreasing order. Decreasing order of AI. Because the idea is like, if we know like we are going to hit this condition, then let's say we have this 1, 2, 4, 6, 10. Like I don't really care about B right now. A. And let's say my sweetness is 15. If it's greater than 15, X is 15, then some way to do it would be like this. Like I choose 1, 2, 4, 6, this is 13 and then 10. In that way I will end up taking all 5. But if I try to be greedy, I first take 10 and then I take 16, I will directly hit 15 in just 2 moves. And like that is the main idea. Like you brute force, like either this condition will hold or this condition will hold. So if this is hold, then you can just try to take all the values with maximum value of AI and see how many dishes you would be able to eat, minimum number of dishes you would be able to eat. Similarly, check for Y. Like if you take the dishes with highest value of B, what would be the minimum number of dishes you would be able to eat? And the answer is minimum of both. So like I will probably show you my solution. So I take all X as input, all Y as like basically I maintain a pair of vectors. Then I first sorted in decreasing order of X and I kept taking as long as my sum is less than X. Whenever sum becomes greater than X, I took answer equal to minimum of how many dishes I have taken so far. Then I sorted in decreasing order of Y, and whenever my sum becomes greater than X, I took answer as minimum of whatever how many dishes I have taken so far. And at last I printed this answer. Any questions on problem C before we move on to problem D? Okay, then I will move to problem D. Problem D says get nearest. There are n plus q points, ai up to an and b1 up to bq, on a number line where ai point has coordinate ai and bj point has coordinate bj. For each j1 to q, answer the following question. Let x be the point among a1 to an, that is kth closest to point bj. Kjth closest to point bj. Find the distance between point x and point bj. Formally, let d1 di be the distance between point ai and bj. Sort d1 to dan, and then in ascending order of the sequence, print the kth smallest value you have got. Yeah, so like the idea here is like, let's first forget about queries. One second. Just one second, looks like. Not sure why writing pad is not working right now. Man, my voice is visible, right? Okay, just 1 second. Not sure why. Like the tablet is not working. And 1 second. So probably I am handicapped today with no writing pad for now. So yeah, like I will try to do it, get it done with mouse for today. So like the idea here was, the idea here is like, let's say we have this as a number line here. There are some cells where A points exist. Let's first forget about queries and let's focus on one specific point here. Like let's say this is the point and we want fifth minimum distance. Fifth minimum distance. So like the idea is like, if you now look at this vector, right? Like this will be of some distance. This will be of some distance. This will be of some distance. This will be of some distance, and so on. And you have like points which you told like D1, D2, D3. D1, like if I look at the sorted order, D2, D3, D4, D5, and D6, and so on. Now the main idea here is we can also binary search on this point. So like we can binary search on this point and we can try to find like what is the value of this D5. The way we can do is like we start from binary search from 0 to like 0 to let's say 10 to the power 1000, and we ask like how many values are less than mid in this array. If the count is less than 5, then we say that our answer would be between L and mid. And if the count is more than 5, we say that our answer is greater than 1 and mid. And if the count is less than 5, then we can say that our answer must be greater than mid and R. Like the another way to look at it is like, let's say we know like how many times 1 appears. Let's say how many times 2 appears, let's say 1, and so on. Then if we count the number of points in an array less than some value here, like that was the idea I had over here. Okay, like now the reason I choose this method, like in a sorted array, if we want to find fifth value, we can use a binary search, where what I am saying is like we can first check like for a given mid how many values are less than that. And because like we know that the for kth value, the values less than it should be less than k over here. Yeah, I can show it with an example as well. Let's say we have this array for now. 1, 2, 3, and let's say we want to find fifth value. Now if I count values less than count of values less than equal to 2, this is 1. Count values of less than 3 is also 1. Count of values less than 5, this has now become 2. Count of values less than 10, 9 is still 2. Count of values less than 10 has become 3. And similarly, if you look at count of values less than 999, this is still 3. And now count of values less than 1000 is 5. And this is the first time when the count has exited 5. So we know that the fifth value must be 1000 here. And like that was the intuition over here. Like I am yet to go through the problem first. What I am saying is, like if you have been asked to find some kth value in a sorted array, you can also use binary search. And this is how you will use binary search. You will start from some minimum value, you will start from some maximum value in the array. Then you will take the mid and you will count how many values are less than mid. If you want kth value, number of values less than mid is less than k, then you jump on one side. If the number of values less than mid is greater than equal to k, then you jump on the other side and you continue binary search. At last, you will find the first point where the number of values would be greater than equal to k, and that is your answer. And the way I did it was I took an example array where I wanted to find fifth smallest value, and like this is how I am doing. The reason why I chose this array to do this, because like let's say we have some point and we want to count how many values have distance less than 100, let's say. Then we know that this is point x. All the values in distance from x minus 100 to x plus 100 will have distance less than equal to 100. So like that is what I am doing here. Now like what I can do is like I can now binary search, like it's an earlier I took a specific array, now I am taking an implicit array where I am binary searching what can be the value in the array if I find distance with respect to a point. So what I am saying is, in the number line I know some point x, and like if I look at the sorted array, then I can definitely use this technique to find the fifth value in the sorted array. That would be like I take some value and I count how many values are less than that value in the array. Yeah, like same distance, how we do when array contains negative, because same distance can be for same value and positive. Like you can also, like it's just your binary search constraint. You can also start binary search with minus infinity and r equal to infinity, where infinity you can probably call 10 to the power 18 if you want. Like you will definitely know like what is the minimum value in an array and maximum based on the constraint here. For example, in the problem statement here, you know that all the points are between 10 to the power minus 8 and 10 to the power 8. So if 2 points are at same point, then the distance between them would be 0. If one of the point is on minus 1e8 and another point is on 1e8, then maximum distance between them can be 2e8. Like there can't be any point in D which has value more than 2 into 10 to the power 8. And like that is the idea here. So now like if I have a fixed point and I want to count how many values in D are less than equal to 100, then the way I would do is like I would look at how many points are present between x minus 100 to x plus 100, because only points in this range would be between 1 to 100. Yeah, like what it does not ask us to print the index of the point here. It just says like print the value here. So like D can have multiple values there. Yeah, like I can show it with at least one example here as well. Let's just pick this one, minus 315. -3, -1, 5, 6. It was not sorted, but yeah, let's not forget. And we have to find third smallest from 2, right? This is what the problem statement asks us to do. Third smallest distance from -2. So like I know like maximum distance between any 2 points, like I will not take much larger value. Minimum distance between any 2 point, like there is no point with distance -1. Like I generally keep my binary search like this. And in this case, I know like maximum distance between any 2 points can be 100. I can take 100, but I don't want to do it because I want to simulate it. Now I look at mid. First mid would be 50. So like any value which is between -52 and 48 will have distance less than equal to 50. How many points are there? Like from -50 to 48, all the 4 points are there. Now in that case, like I will reduce my bounds of the array. I will take now the R is 50, which is mid, because like 4 was more than third smallest I want. Now again my mid is, let's say, 25. I will see like any point between -27 to 23 is at distance less than equal to 25. And how many points are there? All the 4 points are in this range. So the answer is no here. So I will again replace my right boundary here. Let's say mid is 12 now. And for -2, any point with distance -14 to 10 will have distance less than equal to 12. And all the 4 points are there. So I will reduce it further. Now my mid is 16. So any point which is between -8 to 4 will have distance less than equal to 6. Again, all the 4 points are there. No, this is not there. So now there are 3 points. Yeah, it's binary search on distance here, not on the point here. Now, like I know this is 3, and like I want to find the maximum point until which the distance is less than that point. So I can again replace my right boundary with 6. And now my mid is 3. -2, 3 distance is -5 to 1. How many points are there between this? This is 2. In this case, I will increase my left boundary. So like the minimum boundary here would be 3. Now I take mid as 4. So any point from -6 to 2 will be at distance less than equal to 4. And how many points are there? Only 2 points are there. So I will again increase my left boundary here. Now the mid is 5. -7 to 3. How many points are there? Still 2. So the left hand point is again 5. So the answer in this case should be 6. 6 or 7. Like looks like I messed up somewhere, but yeah, that is the idea over here. Like the values from -2 values which are distance less than 5 is 2. And the first answer was 7. Like looks like when I messed up when I was looking at mid equal to 6, but essentially that is the idea here. Yeah, answer was 7. And now how do we count how many values are between some distance L to R? But we nowhere considered But we nowhere considered 2 from start, right? What do you mean? Yeah, like 2 would have been at a distance 0, right? Like this L to R is from 2, right? Only, right? 7, -7 is -2 -5, and 3 is -2 plus 5. So always I am looking at x minus mid and x plus mid, because this is what the boundary is. Because only these points have distance less than equal to mid. And like how do we count values from index L to R? The idea here would be like we can again use binary search on A, or a specifically lower bound and upper bound methods. Uh, that was the another idea. Can you find the location of point B on sorted A and then conclude that the answer is minimum of B minus? I don't think that will work, because the problem here is like for example, you have, I will take some example here. Like let's say this is our point X. It can happen that there are some points very close by here and some points very far away here. And the kth point you are looking for is like this. And the next smallest point is this. So like the points here so far is 4 and points here so far is 2. So like you can have any distribution of over here. Like here you can have some k minus I points, and here you will have some I points. And this I can be anything between 0 to k when you look at the binary search distance. So like any heuristic other than binary search and lower bound, upper bound, I don't think are supposed to work here. So any more questions on this problem before we move on to the next problem? No, it looks like charge was the issue for the pad. So yeah, we can probably, I have writing pad now, like charging was the issue. So in that case, I will move on to the next problem. It says maximum Glutton. The problem is same as problem C. Just that it asks us to find the maximum value instead of minimum we took earlier. Can you explain that range once again? Yeah, I can. My idea first is like if D1, D2, D3, etc. is the shortest vector, then I can binary search to find the value of dk here. Binary search. The way I will binary search is I will have some left and R endpoints. I will pick some mid and I will count number of values less than mid. If this count is less than k, I move my left pointer further. If this count is greater than equal to k, I bring my right pointer further. And now like once I have some fix, and the question is like how do I count values which are at distance less than equal to mid? And here the idea is like if I want to look at values less than equal to mid, I should count the number of points which are between x minus mid and x plus mid. And counting that points, idea is like I should binary search using lower bound and upper bound on A. And like that is the idea I had. Like I will probably show my code once. I think that will make life a bit easier. This was problem D, right? 1 second. So I have first took all the A's input and just sorted them. Now for each query, which I am asking like find the kth smallest point from point B. Now like I want from point P kth smallest distance. I binary search on the distance from B. So L equal to -1, R equal to 1e10, because like minimum possible distance can be 0 and maximum possible distance is 2 into 10 to the power 8. I have a mid here. I count how many points are less than mid. If that count is less than k, I move my left pointer further. Otherwise, I move my right pointer further. basically reduce my right pointer. And now to count number of points at a distance d, what I need is like the number of points which are distance p minus d and p plus d. And here like lower bound and upper bound is helpful where a is sorted. Can you prove above thing? How do you prove that at least one point will coincide at b minus 1, b plus m, such that the number of point is k? No, number of points can even be k plus 1. Like 1 second. No, it's not necessary that there will be a point where, like, let's look at this as a vector A. Or probably let me take some example for this. And like, let's say we have these points A equal to 2, 1, minus 1 and 6. And we have to find third smallest point from P. From 4. So if you look at distance of 4 from all of these points, it's 1, 3, 5, 5. And the answer here is 5. But if you look at my counting table, number of points with distance less than equal to 3 is 2. And distance less than equal to 5, distance less than equal to 4 is 2, distance less than equal to 5 is 4. So like there is no mid where the distance would be 3 here. What we know is like the first time when the distance jumps, there would be some point, right? Otherwise the distance cannot increase. Like distance at 1 was 2, less than equal to 2 was 3, less than equal to 3 is 2, less than equal to 4 is 2, less than 5 equal to 4. So whenever this distance increases on this boundary, there must be a point due to which the distance increases, right? And like that is how we know, like the first time when the value distance becomes greater than equal to k, that is our answer. Yeah, so like first number of points can be k plus 1 as well if there is a point at b minus m and b plus m. And this is the example. And in this case also the answer is still 5. And like here, had the problem statement asked us to also print the index of a point, they should have mentioned whether if there are 2 points at the same distance and are at k smallest, which one should we pick, left one or right one? That would have determined this. So any questions on this problem? Okay, I will probably move to next question then. And like this was the code for this. Problem E is same as problem C. Okay, like Takahashi has prepared n dishes and like the same problem it asks us to find the maximum number of dishes Snooks will eat. Here like the first idea is like we can use a DP here. DPI sum A. Like what I will do is I will find the maximum number of points I can take. Such that sum A is less than equal to x and sum B is less than equal to y. The idea is if I can find this set of maximum point, I will just add plus 1 to the answer above to get an answer. Because like the last time when you take some dish, your or like either sum A will be greater than equal to x, or sum y would be greater than y. So like I try to find how many maximum points I can take such that my both the values are less than x and y. If I can find the maximum set one, then I can just set any of the remaining one to just get a value more than that. So the problem reduces to count how many points you can take such that sum A is less than equal to x and sum B is less than equal to y, and add plus 1 to it, and that would be your answer. The answer can obviously fail if you can take all the n points because there's no n plus 1 dish there. But in that case, you stop because you have eaten all the dishes. You don't stop because your value is greater than x or y. So this is what I want to find. The first dp is dp idx sum a sum b as maximum number of points dishes I can take if I only consider first idx dishes, basically a1 a2 up to aidx, and sum ai taken so far is less than equal to sum a, and sum bi taken so far is less than equal to sum b. Both sum A and sum B are up to 1e4. I am not claiming this is the optimal answer. I am just sharing a brute force approach first. Then I will optimize based on it. And at last, what we need is like dp and x and y plus 1. Any questions on so far? Like this approach should give me the correct answers. I'm not saying it will not get TLE, but at least it should not give me a WA. Assuming that the answer is like there would be a condition like basically in the input constraints sum of all ai and sum of all bi is greater than equal to x and y, whatever is there. Like the only corner case is when even if you take everything, your sum does not exceed x or y, any of them. That we can handle separately. So any questions on this brute force idea first? Overall, the time complexity here would be order of n into x into y, which is around 89, and will definitely give us TLE, but any questions here like why this approach should give us the correct value even if it's a TLE? Like TLE to AC I will do the optimization next, but any questions here first? Like the idea is if your transitions will look more like this: dp idx sum a sum b equal to max of, if you don't take anything from the ith index, then this would be the number of dishes you will be able to take, and if you take the current dish, then you should take max of 1 plus dp idx minus 1 sum a minus ai sum b minus bi or idx, whatever we call it, take and not take dp. And here like sum x and y are up to 1e4 and n is also 80, so overall it's 89, which will definitely give us 2. The idea is to flip the dimensions here. Right now we are maximizing number of dishes taken. We can flip dimensions as well. The idea is dp idx taken count sum a as minimum possible possible value of sum B if we taken count number of, like let's say this is count. Taken count number of dishes and their sum AI is equal to sum A. And at last what we can do is like we can look at DP and like assuming like taken count, and so far we have only considered first IDX dishes. So at last what we can check is like DPN, like we have considered all the dishes, sum J, like the number of dishes we want to take, and all sum A equal to 0 to X, and if this is less than equal to Y, then answer equal to max of answer comma J. Like the same thing earlier, we were maximizing the number of dishes we want to take. Now what I'm saying is like I am adding number of dishes in the DP dimension and I want to minimize the sum of values of B. And this is the solution for this problem. Overall, the time complexity here would be order of n for IDX variable, n for number of dishes taken, and x for the number of values taken, and this is around 800 into 1, 2, 3, 4, which is around 8 E6, and it gets an AC. Any questions here? Like the DP state would be similar, take, not take, and you take minimum in a range, and that is how you do. Like I will probably implement it because in the contest I did things slightly different. This was problem E, right? Or D? Yeah, problem E. First thing, this is brute force solution, we don't need it. First thing was like, is the answer N? That I checked by. No, we don't need a such constraint here also. So the here idea is vector via n plus 1 via x plus 1 and infinity. DP, like we have considered only 0 values so far. Sum of all, we have taken 0 values so far. Sum of AI is 0 and sum of BI would be 0. Minus 1 got 1. LLI, count number of indexes taken over up to n. Like if we don't do anything, then DP IDX is just DP IDX minus 1. Otherwise we take some value. PVRA is 0. PVRA plus AI is less than equal to x, and PVRA plus plus. dpidx count plus 1 pvra plus ai is minimum of whatever be the current value is, comma bi plus dpidx minus 1 count and pvr sum. Answer is like we can take at least one diff always. If up till index I take j values with sum of values as a n, and sum of b I got so far is less than equal to y, answer equal to max of answer comma count plus 1. That plus 1 is for the last step which I will take at last. And this is my solution for problem B. Any questions on this one before we move to problem F? But some should also include which are just greater than x, but one step before eating it was less than. Like that is what I am doing. Like I am first taking how many values I can get before I reach the threshold, and whatever be the maximum I can try to eat I got, then I just directly add 1 plus 1 to include for the step when it will cross the boundary. Like to be honest, Rishabh, like I did found this problem really hard. And like in contrast, I ended up doing some convex cell, etc., not trying to prove anything. So yeah, like this was second hardest problem in the contest. Although number of people on standing shows the problem is easy, but I found this non-trivial. So any questions on problem E before we move to problem F then? Like there are definitely problems similar to this one where you try to reduce the dimension and minimize maximize something. Like I can probably try to search for them, but yeah. So like let's move on to problem F then. It says range connected MST. There is a graph with n plus q vertices numbered 1 to n plus q. Initially the graph has no edges. For this graph perform the following operation I equal to 1 to r. For an integer j satisfying this, basically you have been given two endpoints and you have one vertex. That vertex connects with cos ci to every vertex in that range. Determine if the graph is connected after all the operations are completed. If it is connected, find the cost of minimum spanning tree of the graph. A minimum spanning tree is the spanning tree with smallest possible cost, and the cost of spanning tree is sum of all the cost of edges used in the spanning tree. Like overall, it can get really because like let's say if Li is 1 and Ri is n for all the edges, you will end up creating n square edges, and we cannot sort n square edges to get whatever result we want, n into q edges. So like one critical observation here was like critical observation here was like you have some points 1, 2, 3, 4 up to n here, and every point from n plus 1, n plus 2, n plus 3, n plus 4 so on up to is only connected with the specific range here. For example, this LI can be like this. And then for example n plus 2, like you can probably have a range like this, and probably n plus 3 can be connected to nodes like this, and this can be probably connected to 2 3 nodes like this, and so on. But the important thing is this is always a continuous block of nodes here. And the main observation here was like, let's first sort the edges. Like let's first sort based on the values of Ci, so that whenever we see an edge and if we see like that edge can connect to multiple nodes, we will take the smallest one. Like first idea is to sort all the Cis. And notice that each J is only connected to a range only. So for each point, we will have to definitely take at least one edge. Let's say we have processed all the edges with J equal to 3, 5, and 10. Some particular part. And among all the points, it can be possible that the nodes connected with J will form this block. Nodes connected with 6 can form a block like this. Of basically this denotes the points here. Like I am just using rectangle to show like this is the continuous range of points. And nodes connected with 10 can be of continuous block here, something like that. The main observation is like whenever you are completed processing of a particular node, and if you are processing it in increasing order, like nodes like this, like all the connected components will only be continuous ranges. And like that is the critical piece of information here, because it does not make sense if you are connecting this with distance 5 when you are processing in sorted order, and you are connecting this node which is also of cost 5, and these two nodes are not connected with this right now, then like it's always better to also take this with difference 5 before we start processing nodes with cost 6, 7, 8, etc. And like once you realize this observation, what you can do is like instead of a DSU, you can only maintain for each connected component the smallest index in it. Instead of smallest node in each component. And that is the idea. And now the idea is like if you maintain a list in a set, we can when we can query using lower bound all the points in range Lj and Rj, and merge all of this and remove, like basically when you are merging range, it's equivalent to removing the higher edge there. And like that was my idea for this problem. Like this set ID contains IDs of all the connected components. The only concern is I will only maintain the smallest index every time. Like I sorted all the edges based on their cost. I initially inserted all the endpoints. Now when I'm processing a particular edge from L to R with weight W, I will have to add weight W because I want to change N plus J to one of the nodes at least. So what I'm saying is at in the very first instance, I will connect node J with LJ in the first instance. And now I query on all the connected components which have smallest value between L to R. Delete those connected components. Basically merge them with the connected component where L is situated and add a cost W with it. The idea here is, let's say these are the connected components which were formed before your current node. And this is your node and you have these edges. You definitely need this edge so that this node is connected to all the other parts here. We don't need this edge because like this already forms a circle, but we can take this edge. Now like this will be a single connected component here along with some edges from this side. Now we should also take this edge so that this complete is a connected component now, and so on. That is the idea. Any questions here before I call it a day today? Like any questions related to this contest or any other problem or like any generic advice or something which you would like to ask me? Like I will probably take 5-10 minutes for the questions from the chat and then I will probably end the stream. And whoever is here so far, thanks a lot for joining today. Could you share some good problems on binary search? Like I generally suggest people use your guide and CSCS. So like you can start with this. Like some introduction is there, but it pretty much covers like find the maximum x such that f of x is true. Like this is something we were trying to do. Find minimum x, maximize median. Like this was the idea I was trying to use today. Like I know like for some point the number of coordinates with that distance would be less than this and then higher. Off by one, like there are some common mistakes with binary search as well. And some there are built-in binary search method, etc. as well. So you can probably try out. Like Ericto has a lecture by the way on tutorial on binary search. Yeah, like 30, it allows you to understand stop guessing plus one random places, etc. So you should probably try out this lecture by Ericto. My rating on CF is 1560 to give you a rough estimate of my level. I can't solve difficult DP tree graphs of OR. Can you tell where can I some standard problem to practice? Like if your target is placement, like there are like three things you can probably try out for. There is some neat code 75 seat. I haven't tried it, but a lot of people do try it. You can neat code ni blind 75 something. That would be one. Like one thing which I end up recommending is top 100 interview questions lead code. There is a problem list. So that is something you can try out. And there is one A to Z Striver seat is also there. So like you can start one at a time. Like these are the three resources which I generally end up recommending people. So you can start with any of them and go try to solve the problems there. And that would be my recommendation. If the question is like how to practice for online OI, etc. Any more questions from the people in the chat before we call it a day today? Not sure why this lead code is not loading, but like there is one such sheet on lead. Like internet is a bit flaky probably, but there is a sheet on list of top 100 interview problems on lead code. Can I do 2 DP training that you did last week also? You can probably do, but like what I like found was like they did not contain a lot of DP problems. Like my idea was like if they were really good, I would have probably created a stream or something on that, and that was the reason I did them. But like those 14 or 25 problem, I don't remember the exact count. They also contained a lot of problems which were not DP there. By the way, like the contests were good, just that if your focus is on DP, then they might not. Either if you are looking for DP problems, then CSCS, and there is one educational Atcoder contest as well. Contest code is DP, educational DP contest. It has around 26 substars. You can probably try out this. Any more questions for the people in the chat? Otherwise, I will probably end this today. Yeah, 2 more minutes and then I will probably end. Yeah, like OS is a vicious cycle. Probably like people feel like they are becoming hard. That's why they want someone else, and because they end up taking someone's else, that's why OS are becoming hard. Probably not something I can do over here. So thanks everyone for joining today, and I think I will end my stream now. Like as a beginner, how to start? Like this is probably most frequently asked question to me, and for that I have a dedicated channel on my Discord server where I have said like what you can do if you are beginner and what I did when I was a beginner. So like the Discord server link is in the description by the way. So you can check this roadmap to Red channel where I say like first thing is you should participate in ABC because like the standard type of problem today we saw binary search and etc. Educational problem and a rated contest happens only in ABC. Like code forces etc. won't find problems like this. And then if you are looking for some standard problem on topic X, you can go to ESL guide or you can refer CP handbook etc. And like there are few more things what I did when I was expert or below when I was targeting 2100 rating and yeah, so you can probably check it out here. So like my very first recommendation is to do ABC, which I'm assuming if you are in stream here, you are definitely doing that. So yeah, thanks everyone for joining today, and probably we will see